Hi everyone, thank you for having us in this year's The Things conference, and thank you for giving us the opportunity to give you this keynote. My name is GlennTvetmarken and I work as a solutions manager in RaaLabs. RaaLabs is a technology company within the Wilhelmsen Group. Today we're going to talk about decentralized LoRaWAN on board vessels. So shipping is the glue of global trade today, and it plays a key part of the world economy. Well, looking at the global emissions, you would also see that this industry is responsible for a huge part of it. Me and some colleagues were sitting the other day talking about what if we filled a RoRo vessel which can hold up to 8,000 cars with Teslas, and we plug those Teslas in to the main source of energy for the ship, moving it forward. Well, the ship would only be able to move 1/3 of the way between London and New York. And that says something about the amount of energy it takes to move cargo around on the ocean. But it also tells us there is a huge savings potential if you can tap in and make this more efficient. So the past couple of years, RaaLabs has been busy building a business around collecting data and understanding data from vessels. We have built this flexible digital infrastructure we could bring on board to retrieve data from sources you would typically find there. We have built a pipeline, a software pipeline, to retrieve the data, to understand it, to transform it, and to send it to shore or use it on the vessel. And also we have the possibility to host applications to give the crew and the people using the infrastructure on board access to the data without sending it to shore. So going on a vessel today, you would typically find all sorts of sources to data. Some data is easily accessible through existing infrastructure, but a lot of data is stowed away on dark, remote places of a ship. Pulling cables on these steel giants can be quite expensive, let's not say impossible. So making an ROI of a use case can be quite challenging. And the fact that vessels are mobile, they're sailing around the globe with only a VSAT to send data back to shore, makes the solution you bring on board need to encounter these issues and have a flexible way of storing the data, but also sending when you have other means and opportunities. And in the recent years, we also seen that certifications and the security is getting more and more important, especially looking into the operational data which we are looking at. And the cybersecurity threat to this is just exponentially growing, and the risk you're taking needs to be mitigated. So for having a solution that can encounter all of this, we need to do a lot of back work. So why LoRa technology? And what is decentralized LoRaWAN? Well, until recently, LoRa supported 800 and 900 megahertz, and for a lot of use cases that has been really a good fit and a good technology. But when looking at ships and sailing around the globe, the introduction of 2.4 gigahertz meant something completely different, because now you could bring one technology on board which would be compliant all around the globe. So where 800 and 900 megahertz would have compliancy issues coming into different ports in different regions, the 2.4 gigahertz frequency area is not regulated in the same way. And that is a good thing. But the challenge with the 2.4 gigahertz frequency spectrum has been that it hasn't performed really good on ships, at least when you look at technologies like Wi-Fi, for example. But for LoRa, using chirp spread spectrum modulation, that is a benefit for us, and it has proven itself for the tests we have done on board ships, and that's kind of the game changer here. So we have really good results on testing this technology on board vessels like a RoRo vessel, for example, which is like 200 meters long and a lot of steel. And if we need more coverage, we could add more gateways. But with 3 or 4 gateways, we were able to actually cover a whole ship. Going into the decentralized element of this. So why did we decentralize the LoRaWAN? Isn't it good like it is with the big ecosystem that LoRaWAN is and the way you could use it? Well, we talked about the backhaul and the occasionally connected element of this. And For a ship sailing around the world, it only has like a thin VSAT to send data on, and that VSAT is often congested by other traffic as well. So in order for us to send data and also mix it with other data from other sources, we had to pull the data out on the ship. And since we built these hosting capabilities on board already, we thought we could host the LoRa or the TTI open source LoRa stack on that environment. So we did. We put the join server and the application server and the network server from the open source TTI stack, which were available. And by having this in place, we were able to merge data, which we already had from other sources, with data coming from LoRa sensors on board. And also another thing, by decentralizing it and putting it into a hosting environment, you of course need to maintain and patch and update it yourself. But we already had an operational routine for that and a business around that. So this has been a really good fit for us, and we now can progress with a lot of new use cases to solve, having this in our hosting environment. So for us, building new use cases now, we could tap into the sensor ecosystem that lies within the LoRa family and the LoRa community, and it's much easier now for us to drive innovation, knowing that we could reach out to experts on sensory and have the radio mounted and be able to then start solving those use cases quite quickly once the infrastructure is in place. And of course, working with the TTI group, we're able to build a strong roadmap for where we can take this technology inside our hosting environment, but also in merge with what we see on the bigger LoRaWAN picture. So how does the TTI LoRaWAN stack benefit our solution? By hosting this technology inside our infrastructure, we're now able to get sensory out on equipment and places on the ship that we haven't been before. We're able to solve new use cases, having a cost-effective way of getting the data. And we're able to expand our ecosystem, talking to new interesting experts on different domains, and being able to bring them into a fruitful discussion around the data and getting the data insights. So getting the data to the right people and to the right experts is a part of what we're trying to achieve here. Having an ecosystem which could live inside the infrastructure, where we could discuss the data on the ship and on land. And of course, being able to standardize this data on top of the infrastructure and having a simplified way of retrieving data is key. And also looking into the security element of this is really important for us. So back to the example of the Teslas we were talking about, having 8,000 of them on board the ship. I don't think we ever will be able to power a ship and move it from London to New York, but maybe we could take it from 1/3 to 2/3. And that would be a fantastic effort, thinking about the greenhouse emissions and the environmental footprint that shipping has. And maybe LoRaWAN can help us in getting to in the right direction to a more sustainable shipping industry. I don't think there is a zero or an obvious zero emission solution for the industry as a whole, but I think all these small types of innovations will drive it in the right direction. So hopefully the next time we talk, we have been able to solve a whole lot of new cool use cases, and we've been able to leverage more from the LoRa technology. So I will thank you all for listening in to this talk, and hopefully we'll see each other next year. Have a good conference and stay safe.